Okay, now let's look at an example where the numerator has a higher degree than the denominator. So something like x squared plus 3x plus 5 over x plus 1. All right, as we look at this in a normal viewing window, this looks like a rational function. It's kind of funky, looks like two parabolas kind of, and but it doesn't look like it has any horizontal asymptotes, and that's because it doesn't. And as we zoom out, we see that there is some sort of end behavior as x gets really large. And there actually is an asymptote that is a line, a diagonal line. So it's actually at y equals x plus 2. All right, if we look at the middle of the graph, no real relation to the line y equals x plus 2. But as you zoom out, they're pretty much identical. All right, and there's a reason why this happens, and it has to do with kind of things that we just talked about. So if you were to take this function here and do long division, so do x plus 1, do x squared plus 3x plus 5, and do long division, we could rewrite this as something else. And I'm going to pause and do that to save you some time. Okay, so that function that I have circled in purple could also be rewritten like this. All right. Now, if we look at what happens as x approaches infinity, all right, this part of the graph is going to equal 0. So as x gets really large, these two graphs are going to look very similar, which is why this line of x plus 2 describes the end behavior of the graph. All right. So when the degree of the numerator is bigger than that of the denominator, there's going to be no horizontal asymptotes. Instead, you want to do long division and see another way to write the graph as a polynomial plus a rational function. And if we look at that rational function here, notice how the degree of the denominator is bigger than that of the numerator. So, like, another reason to understand why this is going to equal 0 when x gets really large. So you can actually extrapolate that idea and for other types of functions. So make a prediction right now. If I were to erase all this and make this a third degree polynomial, so I'm going to hit 3 and I'm going to hide this graph here. Oops, sorry. But pause the video and try to figure out what type of end behavior would this have? What would the asymptote look like when it's a cubic over a linear? Okay, if you zoom out, you could see that it kind of looks like a parabola. And that's because if you were to divide a cubic by a linear, it would equal a parabola. It would equal x squared. And let's actually do that right now. So if we were to do long division here, we would see that this graph, this equation, would simplify to this. So if I were to graph x squared plus 2, that would have a y-intercept of 2 and look something like this. And that is what describes the graph of this y that I'm circling another time when x gets really large. All right, so it's all about when the degree of the numerator is bigger than the denominator, use long division, and the polynomial part of your answer is going to be what the graph looks like when x gets really large, because this part is going to approximately equal 0 when x gets really large, right? When x is 100, that's going to be 3 over 101. Is that going to really do much? That's like less than 3%, less than 0.3. Is that going to do much being added to that? Not really. It would be the same thing as like this plus that. Like if I were to graph this, you couldn't even tell the difference. Okay, so in summary, to find horizontal asymptotes, if the degree of the numerator is less than that of the denominator, all right, so the bottom is bigger, you're going to have a horizontal asymptote at y equals 0. When the degrees are the same, all right, you're going to look at the leading coefficient, and the horizontal asymptote will be at y equals a over b, all right, the quotient of the leading coefficients. And if the degree of the numerator is bigger, all right, f of x has no horizontal asymptote, but there could be a slant. Now I say could because that's a slant implies like a line that's only going to be when the numerator is exactly 1 more than that of the denominator, all right? If the degree of the numerator is 2 more than that of the denominator, so something like this, then you would have like a sort of quadratic type of asymptote. All right, and that idea kind of you can extrapolate that. If you had like a 5th degree polynomial over a 2nd degree polynomial, then your asymptote would look like a cubic. All right. So slant asymptotes only occur when the degree of the numerator is exactly 1 more than that in the denominator. And to find that equation, you divide the rational functions using long division, and the quotient without the remainder is the equation of your slant asymptote.